Warning! In today's video, we will be using high voltage. If you do not know what high voltage is and how to use it properly, please do not try anything you see at home. Oh, did I mention high voltage is fun? Yeah. Yeah, high voltage. Alright, so there are many ways of building a power supply, high voltage power supply. One of them is ZVS. Very powerful, not efficient, easy to make. No need for tuning except the capacitor right here. There's also another way, and that's using op amps. So all you gotta do is you set a 2 op amp oscillator, which gives you a square wave and gives you a triangular wave, which you use a triangular wave to feed into this circuit right here, which uses 4 op amps, which allows you to control the duty cycle between 0 and 100%. So perfect. You drive a MOSFET that drives your primary on the flyback. Bob's your uncle. So the problem is that although I had tried many of these circuits, I want to build something different today, and we'll be using this guy. Power breadboard is what I call it. Has 2 power supplies, so the top rails are connected, the bottom rails are connected, and 2 knobs allows you to have 2 voltages. So pretty handy when building small circuits. And the enclosure I'm planning to use for this power supply is actually this one. It has no front or back, as you can see. It's from old cassette player, but still it's relatively good size is what I like. So we will use this one. In terms of a ZVS driver, I have this very powerful one. This can take lots of power. I mean, this can burn flybacks. This will vaporize these wires. So I really don't want to use this one, so if I have to, I will build 1 or 2, but I would prefer not to use a ZVS since it requires a great power input, so I want to keep the project simple. So most likely, I really hope I can use a 555 timer chip for this project. That's what most people use, and yeah. Alright, now the next thing that you should consider when building something like this is obviously how are you going to carry the output. You cannot just use regular wires to carry the output, so you gotta use something like this. This is a high voltage cable I made. If anyone is interested, It's very simple and very cheap. You would not believe how cheap it is to make this. If you want to know how to make it, just write it in the comments. The more people I get, faster the video will come out. So yeah, so that's what we will use for our output. Oh my goodness, this project takes more time than I thought, and this is just impossible. And I am serious. I don't know how this happened and why it's not working, but I burned about 10 555 timer chips, a whole bunch of transistors, MOSFETs, and flybacks, and I cannot get the spark I want that I had before. So I don't know. I really don't know where this will go. This sets me at least 2 days back, so I pretty much have with what I started with 2 days ago. I got nothing, and the only solution I have is a ZVS driver, because either I have a cheap Chinese 555 timers and transistors. I don't know. Well, I didn't pay much for them, but they just burn, heat up, and release the magic smoke. So I don't know what's going on, and I tried at least 10 circuits, at least, and it's just not working. So the plan is to go back to a ZVS driver and see where we go. Guys, so this is the setup. We got a ZVS driver right here. We have a capacitor bank right here. Big beefy inductor for the flyback. And we're using the center tap coil. This is the output cup, vacuum cup. And it will arc right here. So that's about it. ZVS is simple, so let me see what it can do. Now the problem associated with filming ZVS is that it's dangerous for your camera. So just for you, I'm gonna show you what it can do. So turn on high pitch sound, just like it should be, and then arc. Oh yeah. Okay, that's enough. MOSFETs do not have a heatsink, so they are hot. Yep, they are hot. So I think that's what I'm gonna use. Just experimenting with different capacitance to ensure that we get the proper frequency. Alright, so what I have did is I had disconnected this bank and this bank. So, and I replaced it with a single capacitor, and we get a very different result now. It doesn't make a high-pitched sound, but I noticed that the voltage is higher. We get more voltage and less current, so this is the kind of arc I need. So I'm gonna try to decrease the capacitance and we see where it goes. Alright, so plan is to get a heatsink and a fan like this, and mount 2 MOSFETs like that, and take a PCB and mount it over the MOSFETs like that with some standoffs, and then we're good. Now I do want to one feature I did not find anywhere on any ZVS circuit on the web, and that is auxiliary on off. So obviously you do not want to turn off a couple amps of current with the switch because it's not efficient, so you can just make an auxiliary signal input on off thing, and it will turn on or off the ZVS. Yeah. Now the reason we actually can do auxiliary on off is due to the circuitry that the ZVS is using. So, and that is only possible because of these two 10K resistors, which I had changed. It's no longer 10K, it's 5.1K. The MOSFETs run much cooler because they turn off faster. I might do some shots on my oscilloscope later, but eventually when you do not feed any positive here, from here, and you do not feed any positive, they cannot turn on. So because they are pulled to ground, therefore both of them are off. So a simple relay should do it. I hadn't tested my theory yet, but we'll see when I build this guy. Alright. Right guys, so I've been doing some circuitry on the side for ZVS, but anyway, we had to complete the heatsink assembly. We drilled the holes, we mounted the MOSFETs with silk pad and thermal compound. Our driver is done as well. We have our fan output, we have our auxiliary on input, and it's done. All we have to do is solder the gates there, put some fast recovery diodes on there, and we're good to go. Alright guys, so the MOSFETs are almost connected to the control board. We have our negative, which is not connected yet, but the outputs are soldered, and the gates will be soldered in a couple of seconds. So it's almost done and it's almost ready to run. So realistically we should be able to finish this thing around in 10 minutes, and we should be able to test it. So yeah. Alright guys, so our driver is done. All the components are in place, and yeah, it just looks beautiful, I have to tell you. Now I'm honestly surprised by the way this one looks, because this is the previous one I made, which is more powerful. It uses IRFP 260N MOSFETs, but still this one looks like a Frankenstein, while this one looks nice and neat. I actually like this one more, but this one is way more powerful, just way more powerful. There is no alternative at the moment for this guy. What gauge is this? This is 8 gauge wires. 8 gauge wires. Under 10 amps, this gets a little bit warm. I don't know how this will perform, but yeah. So let's test it. Alright guys, so what we have done is we had just finished our ZVS. Not tested yet. I do not know if it will work or if it will blow up. So hopefully all of these timers and MOSFETs hadn't been a waste of time, because if that's the only sacrifice I had to do to make this thing, it's a win-win. So let's start assembling this thing. Alright guys, so everything is connected. The switch is in the off position, so I'm going to turn on my ATX and the fan starts. So that's a good sign. That means that LM317 is working. Yeah, pretty much. So yeah, it's off. So very nervous moment. You are ready? Oh, yes. Yes, it's working. Oh, something happened. Oh. Now, this is really interesting. Okay, it's warm. The lamp 317 is warm because it's driving the fan. The heatsink, it's warm, but I think, yeah. So the resistors are warm. What about the diodes? Diodes are fast recovery diodes are warm. So we're okay. We're okay. This is just magic. Now, by the looks of it, it's arcing about 1.5 centimeters from between the contacts. So I would say there's about 12 to 15,000 volts and high amperage. So remember when they said high voltage kills you? No, they lied. Current kills you, but realistically saying, when there's not enough voltage, the current cannot kill you. So you can hold two pieces of wire like this that are capable of 1000 amps, but there's only 1 volt, so you won't even feel anything. So yeah, it all depends, right? So realistically saying, I can probably touch it with my finger and arc it from my finger. Now probably my skin will start to burn due to plasma, of course. But yeah. Alright guys, so we had accomplished everything we wanted today. We have a beautiful, just beautiful driver. Probably one of the best looking drivers, ZVS drivers on YouTube. And yeah, I'm just proud of what I made. Because it doesn't look like a Frankenstein, the one I had before. So this one has additional features like a fan driver, adjustable gate driver, as well as auxiliary on and off. So really cool, very useful, fully self-sustained unit. So we can cover the module. Now part 2 is coming. We will build the enclosure and case all of this goodness inside, connect the flybacks in series, and play with high voltage later. Yeah, so all looking good so far. So thank you guys for watching, and if you liked the video, please leave a like, and also don't forget to subscribe to my channel so you'll know when a new video comes out, and see you next time.